Hey guys, welcome back to the channel. In this video, we are going to understand Raoult's law in a easiest way possible. Now, before understanding Raoult's law, it is important that we understand the meaning of vapor pressure. Okay, so first of all, let us understand the meaning of vapor pressure. So for that, let us consider a closed container. And inside this closed container, let us take a volatile liquid. Now, a volatile liquid evaporates even at room temperature. So as we all know that when a liquid evaporates, it is obviously going to give us vapors. Am I right? And these vapors are going to get trapped inside this container because this is a closed container that we have taken. And guys, you observe one thing, that initially the liquid gets quickly converted into vapors. So guys, can I say that initially the rate of evaporation is fast? Why? Because the liquid is getting quickly converted into vapors. Okay. Now, after some time, you make two observations. Okay. So after some time, you make two observations. The first observation is that now also the liquid is getting evaporated and forming vapors, but this time it is forming vapors slowly. So guys, can I say that now the rate of evaporation is decreased? Why? Because now the liquid is forming vapors slowly. And you observe one more thing. You observe that some of the vapors are getting converted back into liquid. And we all know vapors getting converted back into liquid is called as condensation. So guys, can I say now the condensation is also started? Okay. Now again, after some time, you reach a stage. Okay. You reach a stage, and at that stage you observe that a dynamic equilibrium is being established. Now, what is the meaning of this dynamic equilibrium? Dynamic equilibrium means that the amount of liquid getting converted into vapor will be equals to the amount of vapor getting converted back into liquid. Which means that at dynamic equilibrium, for example, if 10 moles of liquid gets converted into vapor, then 10 moles of vapor will also get converted back into liquid. Okay, so this is what happens at a dynamic equilibrium. So guys, can I say at dynamic equilibrium, the rate of evaporation will be equals to the rate of condensation. Why? Because the amount of liquid that is being getting evaporated is equals to the amount of vapor that are getting condensed back into liquid. Okay, now we have achieved a dynamic equilibrium. Now at this dynamic equilibrium, can you see some vapors that are present? Okay, these vapors obviously carry some mass. So these vapors are going to now exert pressure on this liquid. Okay, so these vapors are going to exert pressure on this liquid, and this pressure exerted by these vapors is called as vapor pressure. I hope you have understood what is vapor pressure. So let us quickly define vapor pressure. What is vapor pressure? The pressure exerted by vapors on the liquid at a dynamic equilibrium. This is an important line. At dynamic equilibrium, you cannot consider the pressure of vapors at any stage. You have to consider the pressure of vapors at dynamic equilibrium. Okay, so I hope guys that you have understood what is vapor pressure. And guys, we represent this vapor pressure as P naught. Please make note of this. This is a very important statement. Otherwise, you all will get confused afterwards. Vapor pressure is represented as P naught. Okay. Now, after understanding vapor pressure, let us understand what is Raoult's law and why we need Raoult's law. Okay. So for that, what I'm going to do is that I am going to consider two volatile liquids over here. Okay. So I have two volatile liquids over here, and I will now mix these two liquids. And after I mix these two liquids, obviously I am going to get a solution. Okay. Now let's name these liquids. Let's name this yellow color volatile liquid to be A and this red color volatile liquid to be B. And obviously in the solution we are going to have A as well as B. Now how do we represent vapor pressure? We represent vapor pressure by P naught. So let's say that the vapor pressure of A is P naught of A and vapor pressure of B is P naught of B. Clear with this? Clear up till here? Now, my one question to you all. Listen carefully. What will be the vapor pressure of A in this solution? Will it be P naught of A? The answer is obviously no. Why? Because here A is a pure liquid. Only A is present in this container. Whereas here we are having a solution. Therefore, vapor pressure of A will be different over here. Okay. Similarly, what will be the vapor pressure of B in this solution? Will it be P naught of B? Obviously not. It will be some other value. And let's assume these values to be PA and PB respectively. Okay. Now, what is the meaning of this PA? What we are saying, this PA is nothing but vapor pressure of A in the solution. Okay. But we must use the terms partial pressure of A in the solution. Why we are using partial pressure of A? Because along with A there is another substance that is present. Okay. So therefore we need to use the term partial. Okay. So whenever you are saying vapor pressure of A in a solution, you must say partial pressure of A. Okay. What you must say? Partial pressure of A. Whereas here, where there is only A present, there you can say vapor pressure of A. But here, since along with A, some other substance is also present, therefore you must say partial pressure of A. Similarly, this PB, what is this PB? PB is nothing but partial pressure of B. Okay, because along with B, there is some other substance also present. Now, what is the value of this PA and PB? This we get to know with the help of the Raoult's law. Okay, so Raoult's law helps us to find out the value of PA and PB. So let's see what is Raoult's law. Raoult's law tells us that the partial pressure of A is equals to XA into vapor pressure of A. Okay, see. Let me take you all back. See, partial pressure is represented as PA. Therefore, see, I have written over here. Partial pressure of A, PA, is equals to XA into P naught of A. And I hope you all remember what is this P naught of A. This is nothing but vapor pressure of pure liquid A. Clear with this? Now, what is this XA? This XA is nothing but mole fraction. Now what is the meaning of mole fraction? If you all do not know that, then guys please hold on for next 1 minute. Okay, for next 1 minute, and I will explain you all what is mole fraction. Okay. So this is what Raoult's law tells us, that the partial pressure of A will be equals to mole fraction of A into vapor pressure of A. Similarly, it tells us that partial pressure of B will be equals to mole fraction of B into vapor pressure of B. My bad guys. Partial pressure of B is equals to mole fraction of B into vapor pressure of B. Clear with this? I hope you have understood these two formulas. Now let us understand what is the meaning of mole fraction. For mole fraction, we have a very simple formula, that is nothing but mole fraction of A is equals to number of moles of A in solution divided by total number of moles of solution. Which solution? See this solution. See, this is your solution. Okay. So the number of moles of A present in this solution will come in the numerator, and total number of moles of solution will come in the denominator. Clear with this? So I hope you have understood what is mole fraction as well. It is a very easy term. Similarly, you might have predicted what is the formula for mole fraction of B. It is nothing but number of moles of B divided by the total number of moles of solution. Clear with this? Now, what will be the total pressure of this solution? What will be the total vapor pressure of this solution? So it is obviously partial pressure of A plus partial pressure of B. If there would have been C, then partial pressure of A plus partial pressure of B plus partial pressure of C. But since we are having only A and B, therefore the total vapor pressure of this solution will be partial pressure of A plus partial pressure of B. Okay. So over here we represent total pressure by, as you can see over here, we have represented total vapor pressure as P. So total vapor pressure of P is equals to partial pressure of A plus partial pressure of B. Clear with this, guys? Now, moving on, what is the formula for partial pressure of A? It is nothing but XA into P naught A. So let's substitute over here. XA into P naught A, and partial pressure of B is nothing but XB into P naught B. And let us name this equation to be equation number 1, and let us keep this aside for next 1 minute. Now, guys, the total mole fraction will always be equals to 1. Why it is equals to 1? That I will tell you all after 3 to 4 minutes, because I don't want to break the momentum over here. Okay. So just remember that for 3 to 4 minutes, the total mole fraction will be equals to 1. Okay. So guys, can I say that the mole fraction of A plus mole fraction of B will be equals to 1. Moving on, can I shift this to the right hand side? So by shifting this mole fraction of B to the right hand side, I get mole fraction of A is equals to 1 minus mole fraction of B. Now guys, what we are going to do is that we are going to use this formula in statement number 1. What was our equation number 1? This was our equation number 1, right? Now, instead of this XA, let us substitute 1 minus XB. So this P is going to be as it is. So instead of this XA, we have substituted as 1 minus XB into P naught, and this XB into P naught B is going to remain as it is. Clear with this? Now, let us open these brackets. Okay, open this bracket and multiply. So P naught into A, 1 will give you obviously P naught of A, and minus XB into P naught of A will give you XB into P naught of A, plus this XB into P naught of B is going to remain as it is. Now, can I rearrange these terms? So after I rearrange these terms, see, I have just shifted the second term and the third term. Okay, can you see over here? I have done nothing special over here. Now, when you observe this, when you observe this term and when you observe this term, can you see something common over here? Obviously, XB is common over here. So let us take XB common. After you take XB common, this is what you get. And guys, this formula is going to help you a lot in solving the numericals. Clear with this? Now guys, let us understand why I said that mole fraction of A plus mole fraction of B will always be equals to 1. So let's understand with the help of an example, short example. Okay, so let's assume that the total number of moles in solution is 5, and out of these 5 moles, let's say that number of moles of A is 2. Now, obviously, how many number of moles of B will be present? Obviously, it is nothing but 5 minus 2, which is equals to 3. So, we have cleared with 3 terms. Total number of moles in solution, 5. Number of moles of A, 2. Number of moles of B, 3. Now, what is the molar fraction of A formula? Number of moles of A divided by total number of moles. So, 2 divided by 5. Similarly, for number of moles of mole fraction of B, what is formula? Number of moles of B, that is nothing but 3 divided by total number of moles in solution, that is nothing but 5. Now when you add this mole fraction of A plus mole fraction of B, you will obviously get 2 by 5 plus 3 by 5, which is nothing but equals to 1. So this was just an example. You can change the values and try multiple times. You will always get 1. Clear with this, guys? So I hope you have understood the Raoult's law and you have understood the derivation. This derivation is important, guys, because you need this formula for solving numericals in your examination. So guys, now let us understand the graph which is related to Raoult's law. Now before that, you must be aware of these two equations which we get from Raoult's law. That is nothing but what? Partial pressure of A is equals to mole fraction of A into vapor pressure of A, and partial pressure of B is equals to mole fraction of B into vapor pressure of B. Now as you can see, there are two y-axes. So on one y-axis, we are going to have vapor pressure of B, okay, and on another y-axis we are going to have vapor pressure of A, and on this x-axis that you can see, we are going to have mole fraction over here. Now let's assume that vapor pressure of A is less than vapor pressure of B. Okay, so we have assumed that the vapor pressure of A is less than the vapor pressure of B. You can assume them to be same, or you can even assume that vapor pressure of B is less than vapor pressure of A. It's your choice. For our understanding, we are assuming this case. Okay. Now, you must be knowing this equation. Mole fraction of A plus mole fraction of B is equals to 1. Okay. So with the help of this equation, if I ask you one question, what is the maximum possible value of mole fraction of A? Then it is obviously 1. Okay. So on this leftmost side of the x-axis, we are going to assume that mole fraction of A is 1. Okay, and obviously if mole fraction of A is 1, then by substituting the value of XA as 1, you are going to get the value of XB as 0. Okay, so over here the mole fraction of XB is 0, and by the right side of this x-axis, what we are going to assume is that the value of this XA decreases from 1 to 0. Okay, so over here we assume that the value of XA is going to become 0 from 1. Okay, so it is going to decrease from 1 to 0 as we move from left side to the right side. Now if the value of XA is becoming 0, then obviously by substituting the value of XA as 0, you are going to get the value of XB as 1. So guys, can I say that if you move from a left to right, what is happening over here? the value of xb is increasing from 0 to 1. Now guys, we are having two equations over here, so let us consider this first equation. Okay, so let me write it over here so that I will be able to explain you a little better way. Okay, now over here this PA naught is nothing but vapor pressure of A, and this vapor pressure of A is going to remain constant. Okay, so XA is something which is varying, as you can see over here. It is decreasing from left to right. So guys, if the value of XA increases, then what is going to happen? Will the value of PA increase or decrease? Obviously the value of PA is also going to increase, and if the value of XA decreases, then obviously the value of PA is also going to decrease. So here we draw a graph related to this. Okay, so let me show you all how a graph is going to come. Now before that, since we have assumed that the vapor pressure of A is less than the vapor pressure of B, so let me assume two values over here. I assume that the vapor pressure of B is somewhere over here. See, on this axis we are having vapor pressure of B, so I assume this value to be over here, and since vapor pressure of A is less, therefore I assume it to be somewhere lower than the vapor pressure of B. Clear with this? Now I draw a graph over here. Let me show you all. Okay, so this is the linear graph that we get for this particular equation. So as you can see in this graph, as the value of XA is decreasing, see, as the value of XA is decreasing from 1 to 0, therefore the value of PA, which we get from this line that we have, is also decreasing. Okay, so it's a lesser value that we are going to get. Similarly, you can draw a graph over here for this equation as well. So over here I'm going to get a graph somewhat like this. Why? Because as you can see, as we move from left to right, the value of xb is increasing from 0 to 1, therefore we are going to get a upwards graph which is over here. Okay, now if I join these two lines, what is going to happen is that if I join these 2 points, I am going to get the total vapor pressure of the solution, that is nothing but P, which is equals to partial pressure of A plus partial vapor pressure of B. So guys, I hope that you have understood these graphs as well, and you have understood the Raoult's law as well. So guys, thank you for watching this video, and go check out my channel where I uploaded physics and chemistry videos. They might be helpful for you all. Guys, thank you for watching this video.